Let's try to understand unions. As we have discussed, you are the legislative member of the parliament. You have kept track of all the details with the help of structures. So with the help of structures, you have collected all the details of the people in your constituency. Now you want to search for a particular person, and it can be done with the help of their name or Aadhaar or any other field. Suppose, for example, let's take two of them. For example, I want to search for a person, and I can search it with the help of his name or with the help of his Aadhaar card or maybe with the help of his phone number. Now I don't even know which of the field I'll use to search for a particular person. I can have any one of this detail, and with the help of that detail I need to identify that person uniquely. Then unions come to the rescue of us in this case. Suppose you are defining an union, and this is used for searching details. I can give a name which will be declared as character array, or I can give his Aadhaar card detail or his phone number. I can actually use any one of this variable, and this union is capable of handling any one of the input in this case. That means you can either enter a name, or you can either enter his Aadhaar card number or his phone number whatsoever. If you look at the memory allocation of an union, as you might have expected, it can take any one of it, so the maximum size required will be allocated. Let's say this is 20 and this is 10 bytes respectively, and this is 25 bytes. What is the maximum size required here? It is 25. So 25 bytes will be allocated. So if I give name, it can handle the input. If I give this integer, which is happening to be 20 bytes, it can handle the input, or 10, it can even handle the input. If I declare only 10 bytes and if I want to search with the name, it is not possible. So the size of the union or the memory allocated to this union is generally the largest of all these variables. That is the major difference between a structure and union. Here, only in the case of structure, we can actually group things. In the case of union, we can use it when we have multiple possibilities, but we are using either one of them. And as discussed, memory allocation to the union is done when an object is created. It can be created in a similar way as structures. Union, the name of the union, search details in this case, and let's say D1. Now whenever this object is created, the memory will be allocated to the union as well. Now after defining the objects for structures and unions, if we want to access these variables inside it, it can be accessed with the help of a dot specifier. I can access the name with the help of D1.name, and I can give the name here. Or if I want to access its phone number, I can access it with D1.phone number, and I can give the phone number 9676 and so on. Similarly, if it is a structure also, it will be accessed in the same manner. But you need to remember one thing. In the case of structure, you can access all of this for a single object. But in the case of union, if you create an object, either one of it will be accessed. If you write both of them, it will be an error. And you probably could have understood why this results in an error when you try to call it with the same object. Let's see a quick example where I'll be accessing a structure. Let's try to look at an example where a structure and its members can be accessed. We have defined a student structure which is having details such as his name, registration number and his Aadhaar card. Now, whenever I have declared an object for the same structure, then the memory allocation happens. And as the memory is allotted to all of these members in the case of a structure, if it is an union, only the maximum size of the memory will be allocated. If I want to access any variable, I can access it with the help of this dot operator and the object. So object name dot registration number, object name dot Aadhaar card. With the help of these details, I can actually take the input, or I can actually access these variables. This happens in the case of an object, but what happens when we create an object which is a pointer? Let's try to look at it. If I create a pointer object, let's say star S1 in this case, the memory will not be allocated. To allocate the memory, we can use system calls such as memory allocation or continuous allocation, and I can allocate the memory according to the size of, now I am creating a memory for this entire structure. So the size that has to be allocated should be equivalent to size of the structure. That can be given by size of struct student. As it just returns an integer to the starting address, I have to typecast it to struct student pointer. Now after this statement, the memory allocation happens, and if I want to access any one of its variable, I can access by writing pointer S1 with the help of dot operator name followed by any name, or this can actually be represented with dash and greater than symbol. Both of these are same. Generally people tend to use this notation as it is much more simpler. You can even write in this approach, or you can even try writing this operator. So if you want to access this registration number, it can be accessed with S1 arrow registration number and so on. This is how you access with the help of a pointer in the case of structures or unions. That's very much about structures and unions. With this, we have entered into the section of data structures. So in our upcoming video, we'll talk about linked list and how it stores the information, the dynamic memory allocation, the joins and everything. Stay tuned.